The launch and deployment of the James Webb Space Telescope marked a turning point in humanity's pursuit to understand the cosmos. For our entire history, we've looked to the stars and contemplated the true size of the universe. With each new generation of technology, the cosmos has revealed itself to be vastly more complex than we had ever conceived. We believed we were grasping the scale of it all. As it turns out, our perspective was profoundly incomplete. With its first major data sets, Webb has unveiled a new vista of the universe, and in one of its largest observing programs, it delivered a single colossal image. This is the Cosmos Webb Field, the largest, most detailed map of the cosmos yet created. Within this frame, which stretches back 13.5 billion years, lies a catalog of over 780,000 galaxies that are forcing scientists to rethink fundamental theories of cosmic evolution. In the next few minutes, we will journey through this new reality. A reality far more populated and advanced in its infancy than our models had ever predicted. To show you the true staggering scale of our universe. To comprehend the monumental nature of this new map, we must first recall what came before. For decades, our deepest perspective on the universe was defined by the Hubble Space Telescope. Its ultra-deep field, captured in 2004 by observing a seemingly empty patch of sky for over 11 days, was a landmark achievement. It revealed a celestial zoo of approximately 10,000 galaxies, some from over 13 billion years ago, and became our benchmark for cosmic scale. Each point of light was not a star, but an entire galaxy containing billions of its own stars. This single image allowed us to estimate the number of galaxies in the observable universe, a number that grew to a staggering 2 trillion. But Hubble, for all its power, had inherent limitations. It operated primarily in visible and ultraviolet light. The light from the most ancient galaxies had traveled for so long through an ever-expanding universe that its wavelength was stretched into the infrared spectrum. This is precisely the light the James Webb Space Telescope, with its giant golden mirror, was designed to detect. It can see through the cosmic dust that obscured Hubble's view and capture this ancient, reddened light. And what Webb has revealed doesn't just add to the picture, it redraws the boundaries entirely. To put the leap in perspective, if the famous Hubble ultra-deep field were printed on a standard sheet of paper, the new JWST map from Cosmos Webb at the same resolution would be a mural stretching over 13 feet on each side. It is a recontextualization of our place in the universe as profound as seeing our entire planet for the first time after only ever knowing a single city. The project that delivered this cosmic vista is called Cosmos Webb. It was the largest observing program awarded to JWST in its first year, dedicating over 250 hours to meticulously scanning a patch of sky about 3 times the area of our full moon. The team combined thousands of separate exposures, stitching them together into one seamless, contiguous image. The result is the largest and deepest view of the universe ever captured, a publicly released map containing a catalog of more than 780,000 distinct galaxies. But what makes this image extraordinary is not only its size, it's the story it tells. This map provides a continuous view of galactic evolution from the universe's infancy, just a few 100 million years after the Big Bang to today, all within a single frame. This isn't merely about seeing more of the same. It's about seeing what was previously hidden and understanding the full context. Where Hubble gave us a glimpse of a busy city block, JWST has provided the entire metropolitan area with its sprawling suburbs and the vast cosmic highways connecting them. It allows astronomers to study not just individual galaxies, but the large-scale structure of the universe itself. For the first time, we can trace the cosmic web, the immense scaffolding of dark matter that stretches across the universe, shaping galaxies and clusters like beads on invisible threads. These filaments, unseen but indirectly revealed through their gravitational influence, are the very skeleton of the cosmos. The Cosmos Webb map provides evidence that galaxies were assembling along these strands far earlier than anyone expected. It challenges our models of galaxy formation, which assumed a slower, more gradual buildup. Instead, JWST reveals that vast, mature galaxies already existed when the universe was less than 1 billion years old. This discovery raises profound questions. How could such massive galaxies have formed so quickly after the Big Bang? Were the first stars more efficient at producing heavy elements than we thought? Did black holes at the centers of young galaxies accelerate growth through powerful outflows and mergers? Or does this force us to confront an even deeper possibility, that our current cosmological models are incomplete, and that dark matter and dark energy play a far more complex role in shaping the early universe than we realize? Each faint smudge of light in the cosmos Webb field is not only a galaxy but a time capsule. Some are so distant that their light began its journey when the first oceans on Earth had yet to form. To gaze upon them is to look directly into the universe's forgotten childhood, a time when cosmic dawn was breaking and the first stars ignited against the darkness. Webb's instruments can not only see these galaxies but also analyze their light, revealing their chemical fingerprints. In doing so, it uncovers the gradual enrichment of the universe, from a cosmos of only hydrogen and helium to one seeded with carbon, oxygen, iron, and eventually the building blocks of planets and life. The human dimension of this achievement should not be overlooked. Thousands of scientists, engineers, and visionaries worked across decades to bring JWST into existence, overcoming countless challenges. The deployment itself was a high-stakes ballet of unfolding mirrors and sun shields, any of which could have failed. Yet it succeeded, and now the telescope has begun to pay back that effort with revelations that shake the foundations of our understanding. But beyond the data, beyond the theories and calculations, there is something more intangible, something almost spiritual. To see nearly 1 million galaxies contained within a single frame is to confront the vastness of reality in a way our ancestors could scarcely have imagined. Every one of those galaxies may contain billions of stars. Around many of those stars may orbit planets, and on some of those planets, perhaps, life has arisen. Perhaps civilizations, maybe even more advanced than our own, are looking outward at their night skies, wondering, as we do, whether they are alone. The cosmos Webb field does not provide us with answers to those ultimate questions, but it does show us something equally powerful, that the universe is not empty. It is overflowing with structure, with creativity, with endless possibility. It tells us that we are part of something vastly larger than ourselves. As scientists continue to mine this map for discoveries, they will refine our models of cosmic evolution, test the nature of dark matter and dark energy, and search for the seeds of galaxies like our own Milky Way. Yet for the rest of us, even without the mathematics and the technical detail, the cosmos Webb offers something profound: perspective. For most of human history, our world was bounded by horizons, the mountains in the distance, the edge of the sea, the arc of the sky. Now our horizon is the universe itself, stretching back almost to the dawn of time, and in that vastness, paradoxically, we find a deeper sense of connection, not isolation. Because in every distant galaxy, in every ancient star, we see the same story written, the story of matter organizing itself against the odds, of light breaking the darkness, of complexity emerging where none was expected. The James Webb Space Telescope has given us more than an image. It has given us a mirror not of glass and gold, but of time and space. In it we see not only the past of the universe, but also a reflection of our own search for meaning. The cosmos Webb is not the end of exploration. It is the beginning of a new chapter, one that will continue to unfold as long as we dare to look upward and ask the oldest question of all: what lies beyond?